today, and I guess this does show that this is exactly why we're here and what this building is called Skills Matter. Okay, it's early morning. Welcome everyone to Inside SQL, the first of this conference. I hope there will be more. I realize it's early morning. We'll have a full day of high-level deep dive sessions ahead of us. So I decided the first session of the day should be an easy start. So I'm going to talk. First, I need to show this. This is the schedule. I'm not going to spend much time on this because we're already late. But I'm pretty sure everyone has the schedule. Very important, if you want to have prizes, make sure you're here for the raffle draw. If you're not there, then we're all going to poke fun of you and you don't get your prize. So, I'm going to talk about query complexity. T-SQL, powerful T-SQL to reduce query complexity. And what am I going to, when I say query complexity, what kind of query am I thinking of? Maybe all of you have queries in their mind. This is the type of query I'm thinking of. And the screen is a bit small. This is only half the query. Here's the rest. As I said, I'm going to do this make this a light start. My afternoon session will be a real deep dive session. This is just shallow. Anyone ever inherited code like this? Yeah? Just a few? You're lucky, because this code is actually formatted. When I inherit code, it usually looks like this. Yeah, I realize, I hear that I'm not the only one. This kind of query is sometimes needed. Well, this kind of query is sometimes needed. There's never an excuse for this. But today we will be looking at ways to reduce the complexity of that query, and our key weapon today will be the over clause. Anyone ever watched cooking shows? Gordon Ramsay, cook-offs, MasterChef? You know there's one secret ingredient for every meal. Salt and pepper. Makes everything better. Today, for the next 90 minutes, the over clause will be our salt and pepper. We will make everything better by using the over clause. My name is Hugo Kornelis. I do a lot of things. Nobody cares about this. The only thing you care about is where you can contact me. If you have questions, if something isn't clear, if you have questions now, just ask them, not you, Gail. If you have questions later, everything has sunk in and you realize, okay, I didn't really get it, I thought I got it, but I didn't, contact me. Also, after the session, you can download the slides and the demo code from this link, spoke@InsideSQL02. The only thing you need to remember is 02, the rest is fairly obvious, I hope. And I think it's the same for all sessions today, except for the 02, of course. So for today, I'm going to talk about the SQL paradigm. Those who have, there is a paradigm in using SQL that you need to be aware of, because it's both a strength and a weakness of the language. Then I'm going to show 4 specific problem queries. First, how we solved them before SQL Server 2005. Anyone here still forced to work with SQL Server 2000 or older? Well, today we are. Welcome back to for a trip down memory lane. Then we will be looking at how the over clause was introduced in SQL Server 2005 and how some of our problems became easier to solve. Anyone here working on SQL Server 2005 or 2008 or 2008 R2? Yeah, I've got a few of those servers myself as well. And then we will fast forward to SQL Server 2012 when there were some major improvements to the over clause and our life really became easier. And the improvements are called windowing extensions, and we will show how our previous solutions got replaced by even better solutions in 2012. And then, if there is still time, and we should have because it's a 90-minute session today, I have a small dessert for everyone. And after that, we will wrap back to the original simple query I showed at the start. So, let's get this started. The SQL paradigm. Anyone here accustomed to using third-generation languages like C#, VB.NET? Few. Well, for those, you know that when you code in such a language, you have to explicitly tell the computer what to do. I sometimes compare this to a morning ritual, like, okay, I switch off the alarm clock, I get out of bed, I take off my pajama, I take a shower, I towel off, I brush my teeth, I get dressed, I have breakfast, I step in the car, I drive to work, I sit at my cubicle and I follow, I start working. That is the third generation language approach. Exactly specify what to do first, what to do next. If you process data, you have to code a loop to process a single row, do what you need to do, move on to the next row, etc. And if there's ways to optimize it, it's your task as a programmer to implement them. Now, this is how I see my morning ritual, but my boss has a different view of my morning ritual. When my boss thinks about my morning ritual, he will just tell me, Hugo, tomorrow make sure you're in the office at 8. And that's how SQL works. You don't tell the computer how to do its job, you only tell the computer what you need done. So if you code in SQL, you specify the results you want. And you let the computer figure out the best way to get there. Maybe the computer decides to brush teeth before showering or while under the shower. Maybe it has completely different ideas about a morning ritual, I don't know. I don't care. The thing that matters is that you only specify the result, and the optimizer, which is a very smart piece of software built by Microsoft and by some competitors if you're looking at other database products, has very smart ways to find a fast way to get those results. We also call this working set-based. We process all rows at once. In reality, the optimizer will still eventually revert to looping over the rows, but we don't care about that part. That's internals. So from a developer perspective, it's a single query that specifies the entire result set, processing everything at once. There are some weak spots with this. And well-known weak spots in SQL were previously percentages of a total, running totals, moving averages, or a difference with a previous row. Does anyone see a leading theme in these four? Again, not you, Gail. You are way too smart to answer my questions. Anyone? Okay, Gail? Now you can... No voice left. Okay, go to her session later today. She doesn't have any voice left. You'll have fun. Okay, so the leading theme here is that each and every one of these problems is defined in terms of something relating to other results. And if you specify everything at once, then when you start specifying, you don't have results. And when you have the results, you're already done specifying, so you cannot refer to those results. And that's a big, major, weak spot of classical SQL. You cannot refer to other results. So sometimes you have to repeat entire queries simply because you want to refer to something that is in the results. And that tends to be slow, and mostly the focus today, complex and yielding very long queries. So let's jump let's jump into the demos and look at how this worked previously. I have already in the sample code that you can download later, you will find this solution. I'm using the AdventureWorks sample database, and then in the setup script, what I do is I create two views. A view salesperson, sales by date, and a view salesperson, sales by territory. Both of these specify grand totals for salesperson grouped by territory or grouped by salesperson and date. And I will create the views. And then I will jump in the first demo, which is percentage of a total. So let's first look at the data we're going to use, which is the salesperson sales by territory table. And what you see is that for every salesperson, you have one row per territory with the count of orders and the total sales amount. Now, a typical report for the salespersons would show some of the key columns from this query. A very simple query based on the view, simply showing per salesperson how many sales they made in each territory. A simple report that will be used by the company. For upper management, they might not be interested in this granular level. They might be interested in a more coarse level, like for instance the total sales for each salesperson. So now I'm going to add a group by on salesperson ID and name, and I'm going to see the total sales. Problems start to appear when we want to combine these results. What if we were to say, okay, Stefan has a total sales of, well, let's round it to roughly 1 million. And now we're going to look at how much he has in each territory. Then there's 233,000. Well, actually, I want to display this as 23%. I want to show that Stefan Young has 23% of his sales in territory 1, and very little sales, only, 3% or so, in territory 3. This might be input for a dashboard with pie charts and stuff like that. That's the BI room. I'm not going to do that. But we want to get this data. Now, if you are unlucky enough that you have to do this on a SQL Server 2000 instance, you already have your first challenge. So, I'm going to present 2 methods that worked on SQL Server 2000. And when there are multiple methods, you obviously want to test both for performance and then pick the one that performs best, or if performance is equal, pick the one that you like best for maintainability. So one way to do this is to take the base query that has a row for each salesperson and territory, and then have a subquery that computes the total sales for over all territories for that salesperson ID, a correlated subquery. This gives us the desired results, and on this small sample set, it's pretty fast. And well, if it's just this, it's not overly complex. Remember, this is about query complexity. Well, if you look at this query and think, this is not complex, I can understand this, even on a Monday morning, remember that this is a view. What if you have not defined this view? What if this is a large complex query? You have to repeat it twice. And repeating a query twice in this construction means that the complexity starts to build. And this is just one single problem. The alternative solution is to use a derived table. This derived table is basically this query. I'm going to put it in as a derived table and then join to this from the other query, which will give me the same results, but also at the cost of referencing the view twice. Or if you don't have a view, repeating the query twice. Percentages are the biggest issue. It's not nice to have to repeat the query, but it's okay. What about running totals? Everyone ever needed to add a running total to a report? I see some people nodding their heads. Either they have fallen asleep or they have had this problem. So we're now going to look at the salesperson by date example, which looks similar, but now the aggregation is based on the sale date instead of the territory. Now, in this report, we might want to add a running total, see how much they have sold unto that date. For SQL Server 2000 and before, the best way to do that was to do, people call this a triangular join. It's a join not on equality basis but on inequality. The first row joins to nothing, the second row joins to 1 row, the third row joins to 2 rows. And if you have 1 million rows, then row number 1,000,000 will join to 1,000,000 minus 1 rows. So you get something quite close to a Cartesian product, which is usually not good for performance. And also, well, it's not really a simple query. There is a way to simplify this join clause, but I found that the simpler version of this join clause usually performs a bit slower. So I use this slightly more complex join clause. And what I do is I grab every row and then I'm joining it based on the same salesperson or a previous salesperson. And if it is a previous salesperson, then the order date should be before the order date of the current row. Let's look at the results. And you will see that the running total is going up. And the running total order count is also going up from 12, add 4 to 16, and so forth. And this running total does not reset when we go to a next salesperson. It just keeps on adding up. Let's take a quick look at the execution plan for this query. And then we already see that a lot of work is going on. The upper part is the first evaluation of the view. Then the lower part has to evaluate the view again. And it uses a table spool. A table spool is usually an operator that can be slow. But in this case, not using the table spool will be slower, because this table spool holds the results, so the SQL Server doesn't have to compute them over and over again, because we're constantly joining to the same rows. And if I zoom in, you will see that the number of executions is 468. So this means that the right-hand side of the table spool is effectively only executed once. The results are kept and reused 467 times instead of constantly reusing them. But this query will be slow if you're using it on a large result set. And in this case, we don't have the problem of non-uniqueness. What if you have multiple rows for the same date? You have to find some way to join to the previous rows, which have the same date, but not to the next rows, which also have the same date. So if there's nothing in the data set to make the order unique, then you really have a challenge that is even beyond the level of what I'm going to talk about today. Remember, this is the morning session. We're starting slow. Now, this, while clunky, is, in my eyes, a fairly acceptable solution if the number of rows is low enough. But not every report wants every running total to be the same. For instance, you might have one running total overall, as we saw in the result set, and another running total that has to reset for each new salesperson. So, going back to the result set, maybe we want, there's the change, maybe we want this total to keep growing, but this total to reset when we change salesperson. It's not uncommon to have such a request. Then this self-join will not work, because now we have to have two joins, and then we get even more Cartesian products than we opt for. So instead of using two self-joins, we now have to do two correlated subqueries. And having a single correlated subquery would have worked the first time, but now we don't even have the option. We need to use correlated subqueries, and correlated subqueries with an inequality predicate. So this is a running total that resets for the salesperson. We're only joining to the rows for the same salesperson, the previous order date. This is the running total overall with the same slightly complexer join query. And this will give me the desired results. And you notice that even on such a small result set, it's already taking some time. And if you look at the execution plan, well, I'll need to bring this up. You will see that an enormous amount of stuff has to be done, and that some of these arrows are pretty thick, and we even get sort warnings. Come on, pop up. Spill level 1, 8 spilled threads. This sounds serious, and it is serious. This means that we didn't allocate enough memory, and we had to spill to TempDB, which is much slower. So there's a lot of nastiness going on this query performance-wise. But what's worse, I now have in the results, I do have the desired effect of one running total that resets and one running total that continues to grow. But what if I also wanted to have the same running totals for the order count? When I joined, I could simply add more columns because I joined to the table. But now I have subqueries. So if I want to add a similar running total for the order count, the only thing I can do is copy, paste. And now I have 4 correlated subqueries. And you can imagine that this grows pretty quickly if you're doing some serious BI with 20 columns. Which is why in SQL Server 2000 we never used this method. Yes, it works. Yes, it's set-based. Yes, we all want to have set-based. Not here. If you actually have to do this on SQL Server 2000, please write a cursor. And yes, never write a cursor, except in this case. Next example, moving averages. Does everyone know what a moving average is? Either we all are sleeping or nobody has a clue about moving averages. Okay, I'm going to go with the latter. A moving average is if you want to have an average of over a small window. It's often used when analyzing the stock market. When you look at the stock prices and you only look at the current price, well, day traders might do that sometimes, but the current price is fluctuating so hard. Donald Trump farts and immediately stock plummets. Hillary Clinton says something smart and stock goes up again. So most traders do not care about those short-term movements. But when you look at the average stock rate for companies that might have been in existence over 100 years now, well, the average of that goes back 100 years. It's probably a bit lower than the current stock rate. And whatever happens today and tomorrow will not influence it that much. And everything that happened over 10 years ago is really uninteresting. Well, maybe even everything that happened over 3 years ago. Most stock analysts like to look at moving average, where they take the stock rates of, for instance, the last 7 days, or the last 30 days, or the last 60 days, and calculate the average of only that part. And then every day when a new stock rate is entered, the oldest falls off, and the average moves along, smoothing out the curves. And that is a very useful instrument for stock traders. It's also used in various other situations. So how do you calculate an average over just the last 4 or 5 rows? That can be hard. If the rows have a row number or something else that is guaranteed to increase by 1 every time, then there are some relatively simple solutions. But let's imagine that this is not the case. So we're looking at the salesperson by date, and looking at the data again, you will see that, for instance, Stephen Young, he has something on August 1, something on September 1, and then something on November 1. So if I'm going to do an average with a join on the last 3 months, for instance, then it will sometimes be 2 rows. And if he actually manages to close a deal on a date other than the 1st of the month, it will be 40 rows. We always want the same number of rows, regardless of the data. And that's where things get tricky. So the basic query I show here, and let me quickly remove this. If I remove this, we have the same query we saw in the previous demo. This is the running totals. Joining data for a salesperson to all the previous data for the salesperson. We don't want to join to all the previous data, we only want to join to the last 3 rows. So I'm adding an extra condition saying, okay, I'm joining salesperson by date to salesperson by date, joining the current row to all the previous rows, and then I'm excluding everything where there are more than 5 rows between the 2 rows I just joined. Does this still make sense to everyone? Joining one row to another row from a previous date, and counting the number of rows in between those dates, which is the third join to the table. If the total is more than 5, then I'm not interested in the row anymore. I just join to it, and I'm discarding it. And yes, this is how it will perform. We will first join to it, then count, and then discard it again. I've never seen SQL Server optimize this to something smarter. So yes, on this very small sample, the results are pretty fast. Please do not ever run this query on your multi-terabyte production database. Your server will probably be working for a few years. Now, in this case, and let's quickly look at the results, we see the average order count. It goes up, and then at one point, you will see that here, even though the order count 1, you expect the normal average to go down, but the moving average does not go down because it's the average of the last 5. So first I had these, then I add this, and the upper one falls off. So we add a number 1, but we also lose a number 1, and the average remains the same. And the similar goes for the total sales. Now in this case, both the average order count and the average total sales are over the last 5 rows, which is pretty simple. But what if, for whatever reason, we want to have 5 rows for this moving average, but 4 rows for this moving average? And if you think this is a weird requirement, go back and look at your stock trader graphs. Very often when you look at analytical graphs for stock traders, you will see 3 or 4 lines. A 7-day moving average, a 30-day moving average, and a 60-day moving average is a very common combination in a graph. So it's, in this case, it's 4 and 5, which is uncommon, but it's just a demo. It could be 7, 30, and 60, and we have 3 moving averages, all looking back at a different number of rows. And just as with the running totals, we can now no longer use joins for this, because then we're joining everything to everything, getting a Cartesian product. So we have to use correlated subqueries. And again, this is the correlated subquery we saw in the previous demo, and then we add this count star to limit it to only the last 4 rows for the order count and only the last 5 rows for the total sales. Now imagine this for 10 columns. And previously I already said, in this case I'm using a view, which is just a single name. What if you don't have a view, but it's a subquery? It's a simple subquery, not too long. You want to do this on a base query that is just a 20-line query. Well, you've got the 20-line query here, and here, and here, and here, and here. 5 copies of the same 20-line queries. That's 100 lines. Plus whatever you already see on the screen. You see where this is starting to get really complex. You see where this is starting to cause maintenance issues. It works. It's not a problem. It really works. It gives us the correct results. Okay, it may not be very fast. And again, there may have been better ways to do this using cursors or other non-set-based tricks. But today I am focusing on the set-based solutions. Now, the benefit of this query is that it is fully ANSI compliant. So if you ever need to port to Oracle, to MySQL, to Postgres, then this query should still work. If you are sure that you will never port, then you can use a slightly simpler query, and I cannot take credit for this. This is a simplified version of a query that was handed to me by Peter Larsson. We will see the original query later, because he posted it in response to me seeking assistance on a problem, and he gave me the assistance, he gave me the query, and then I realized I can simplify it to this for this example. So this is not ANSI compliant because it uses top. Top is not ANSI standard. But it is slightly less complex. We now only have 3 copies of the base query. And we still get the same results, and I think it's also slightly faster. Now, there is one problem with moving averages. They always lag behind. If you analyze stocks on a 30-day moving average, you're actually looking at the average over the past month. What I would like to do is center the average around now. Now, of course, when I look at today's stock, I cannot do the average of the next 15 days and the previous 15 days, because if I have access to the stock prices for the next 15 days, I can make money without the analysis. But when I look over the history and I look at the moving average for over all of 2015, I can easily, for the moving average of, for instance, October 1, take all stock prices from September 15 to October 15, and then I have a moving average centered around that day. You already heard in my description, I'm looking back 15 rows and forward 15 rows. Now this is the Peter Larsson query, where he helped me solve this issue in a non-ANSI compliant way. It uses the same trick, but now I'm doing a select top 3, the current row and the previous 2 rows, looking backwards. And I'm doing a top 2, looking forwards. So why top 3 and the top 2? Because this row includes the equality, and this one excludes the equality. So that the current row is included in this subquery, but not in this subquery. I'm then union all those rows together. So this marked query gives me the current row plus the 2 previous and the 2 next rows. And then I'm going to do an average over that. And there we have our moving average of order count, looking backward 2 rows and forward 2 rows. Same for the sales, looking backward 3 rows and forward 3 rows. And then our total query gives us a centered moving average of 5 rows total for order count and of 7 rows total for sale amount. It's non-ANSI compliant, and as I already said in the comments, for some definition of fast, this is the fastest solution you can find. If you do want to have an ANSI compliant version of this, then you will find that the query actually is a bit shorter. I like this query more for understandability and readability, but it's also a lot slower. 4 seconds for only 460 rows. You do not want to do this on your production data. You also do not want to do this if salesperson sales by date is a slow view. In this case, it's a very fast view. And it's a total of 7 copies of this view. So again, if this view is a 20 line query, you add 140 lines to this query. Goodbye and welcome to the wonderful world of SQL Server 2000. I was going to say that was it for 2000, but there's one more issue that's showing the difference with a row. So I sold 500 units today. I also want to see that that was an increase of 20 over my sales yesterday, or maybe a decline of 40. So I want to show the difference. Well, to show the difference in SQL Server 2000, we basically use the same trick we used in the moving average. So what we can do, I'm sorry, I'm saying this wrong. In SQL Server 2000, we could do this. We could use a join to all the previous rows and then exclude everything except the previous row. So basically the same trick as the moving average, with a moving average of just 1 row and then exclude the current row. Very huge subquery for something simple. If you don't need ANSI compliance, then you can use top. So you can just say, take the order count and do a correlated subquery. This joins to all the previous sales for the same salesperson, order it by order date, and just take the first one you find. You cannot do this with a join. You can do this with subqueries. It is not ANSI compliant, but it is pretty fast, and if you're in the right database, it actually works. And I decided not to do this, because it would be a huge and very complex subquery, and really, if you need to do this, and you need to be ANSI compliant, again, please just write a cursor. Computing the results with a different row is so easy if you can do it preferably client-side, or if you really must do it server-side, then with a cursor, because you simply save the last results in a variable, get the next row, compute the difference, save the current data in the variable, and move on. It's a very simple solution if you do it in an algorithmic way. Set-based, this is hard on SQL Server 2000. But our life got better in SQL Server 2005. In SQL Server 2005, we got our first batch of overclause related improvements. Microsoft decided to give us the overclause. The overclause has been in the ANSI standard for some time. We didn't get a full implementation, we got a partial implementation, but we already had a lot of fun with it. So what we got is the basic overclause. And the nice thing about the overclause is this is the very first construction in SQL that gives you a way to reference the results. Based on how query evaluation is logically defined, and logically defined doesn't mean it has to be evaluated in that order. The actual processing can be different, but the logical definition of query definitions says that where, group by, and having are evaluated first. And then you have your result set. Select only defines how you want to view the result set. So those have to be evaluated first, then you have your results. So the overclause can only be evaluated after where, group by, and having have been evaluated. Which also means that the overclause cannot be used in the where, the group by, or the having. Or the from, I should have added the from there. So it's only valid, the overclause can only be used in the select clause. Technically, you can use it in the order by clause, but please don't. I've never found a way to actually make a valid use for this. Of course, curious as I am, I've tested it, it works, but please don't. So if you need to filter on the results of an overclause, you want to use a view, a derived table, or a CTE to work around this limitation. You can filter on it. You cannot just not use the overclause directly in the where, but you can use it in the CTE and then filtering it on the outer query. So what over does is it gives you access to the whole, to complete groups of rows in the result. So you have your result set, we're going to form groups, and you get access to a single group. If you don't form groups, then the entire result will be defined as one group. We'll look at the syntax later. I thought the syntax was here, but it's later. Sorry. So the overclause in 2005 is most well known for being used in combination with row number and rank, and I think most of the people here have used the overclause in combination with a row number function once or twice, or maybe even more often. It's mandatory if you use them. If you use row number, you have to use an overclause or you will get an error. You first partition the results in independent groups. If you don't, then you get a single partition. And then the result is based on the position of the row based on the ordering. So here's the syntax. Over partition by one or more columns. This defines the groups. This defines where the counting resets. Order by. So then each group is logically ordered, and a row number simply is the position of that row in the group. A rank is the rank of that row in the group, etc. Again, most people know this. This is not where I'm going to spend much time. What I'm going to spend some time on is a lesser known application of the overclause in SQL Server 2005. How many people here know that even in SQL Server 2005 and 2008 you can have a normal aggregate function, sum or average or count, with an over clause? A few people. So a lot of people didn't know this. Yay, I'm learning you guys something. Teaching is the correct word. I'm learning something. I'm teaching you. Okay. So for a normal aggregate function, you can optionally add an over clause, which also partitions the results in independent groups, and then there's no ordering. We're just going to perform an aggregation based on it. So there is no ordering. In 2005, 2008, the order by clause is not allowed in this usage. The syntax is very simple. Order over partition by column. That's it. How does this exactly work? So let's say that this is our result set. And mind you, I'm not suggesting that partition, order, and value are smart column names for your actual production queries. But for my demo queries, they do serve a certain purpose. They save me some explanation to be replaced by this explanation. So we're doing an aggregation, and for that aggregation we add over partition by the column named partition. While processing the query, SQL Server is looking at this specific row. And the over clause gives it access to the result set. So here's a logical copy of the results, and the over clause, because of the partition by, gives access to this set of rows, all the rows that have the same value in the partition column. And then the aggregation is done on this set of rows. So you can do a sum of order and you get the total of all these numbers. Let's look at the demo to see this in action. Good. We're moving back to showing a percentage of a total. Let's first look at how the over clause works. So let's first comment out this. If you look at the basic results, this is the basic. Okay, this isn't. This is the basic query we saw before, just looking at salesperson sales by territory. Now, if I add a sum just like this, I would get an error because I have an aggregate function without group by, and that's not allowed. However, as soon as I add an over clause, the error goes away and I actually get results. And you see in those results that all those rows have the same value and all these rows have the same value and so on. So for Stephen Young we added a column, and that column shows us the total sales for all rows of Stephen Young. And now you can see that if you have access to the total sale amount for territory 1 and the total sale amount for all territories, well, then computing the percentage becomes quite simple. Take the total sale amount, you divide it by the total sale amount over all territories, and then you have a percentage. So this query only references the base view once instead of twice for the original version, and is easier to read as soon as you have for at least once seen this construction. Now if you want to have the result as a percentage overall, so how much is this as a percentage of the total sales for all salesperson? Well, over nothing means we didn't specify a partitioning, so we get the total of everything. And now you will see that this figure 80 million remains the same for all rows in the result set. And you can get the percentage of a total by using the same expression here. Now it becomes interesting if you need to mix regular aggregates and these over aggregates. So what if we have, and let me quickly, never type in a demo. Let me quickly remove this. So we have this basic query, we saw this before, the total sales of every salesperson. We're not interested in territory. This is upper management, they want to see the total sales for each salesperson, but they also want to see who is performing what percentage. So they want to have a percentage column here. You might be tempted to just say, okay, add some total sale amount over nothing, just like we did before. However, we will get an error. The problem we have here is we're summing total sale amount with an over clause. Over clause gives us access to the result set of the query. There is no total sale amount in the result set of the query. It's even invalid in the result set of the query because we group by salesperson ID and name, so we don't have a single total sale amount for the rows in the result set. What you also cannot do, you might be saying, okay, we have total sales in the result set, so do a sum of total sales. This will also not work because the over clause is evaluated as part of evaluating the select. Total sales exists after evaluating the select. So total sales does not exist when the over clause is evaluated. What you actually need to do is you say, I have a sum of total sale amount. This is valid in my result set. So I can insert that, copy, paste, and now we have a valid query. And I have it here, slightly better formatting. And though it looks awkward, with the sum of total sale amount, it actually is valid syntax. And the first time you see this, it's like, what? And then by the time you see it for the 5th or 6th time, you will recognize it and say, okay, I know what this means. And obviously you can then do the division and do the percentage. I didn't include it here. You can also say, for instance, I have a sum of the total sale amount. This is the total sales for each salesperson. And then I want to have the average of that. So I want to compare the sales for Stefan Young with the average of the sales for every salesperson. So this is slightly more useful than a sum of a sum in this case. Stefan Young has 1 million. The average salesperson has 4.7 million. So Stefan really should up his game. He doesn't do very well. Michael Blythe, on the other hand, has over almost 2 times as many sales as the average salesperson. So he's doing fine. This is the kind of report that management likes. And of course, you would then present it as a percentage. So Stefan Young has 23% of the average. Michael is almost 200% of the average, etc. And as you see, this quite complex requirement can be solved quite easily. Moving on to the running totals. Well, actually, the over clause didn't help us in SQL Server 2005 for running totals. What did help is the apply clause. The apply clause is a sort of join. It's similar to a join, but the difference between apply and join is that what you apply here, this part can reference this. With a join, this has to be independent. With an apply, it can reference this. So you can have correlated subqueries in the from clause instead of only in the where and the select. This query does not perform as well as the solutions for SQL Server 2000. So if you need to do this on 2005 or 2008 and performance matters, you might still have to refer back to these queries. But if performance is not the most important and maintainability is, then this is slightly simpler. when you use it for running totals with different specifications, you really get an advantage. Because the running totals with different specifications, as I said before, at that point you can no longer join. Because you join 3 tables, and with the Cartesian product you get way too many rows. But with the apply, you do not have that problem. So you can do an apply join here, and a different apply join here, and then I can add as many columns from those tables as I want without having to repeat the subquery. Remember, in the running totals version with the subqueries, adding more columns meant adding more copies of the subquery, which is horrible. With the apply version, you can just add more columns here. So, for this specific situation, the apply version on SQL Server 2005 is better than the SQL Server 2000 version, or maybe I should say less worse. For the moving averages, there is a new solution in SQL Server 2005. Remember when I started discussing this on the SQL Server 2000 version, I said, okay, if we are sure that a salesperson has a sale on the first day of every month, or there is another way to just specify the row numbers, I can simply join two based on the row number or based on the month number. If Stefan Young would have had a sale on October and every other month, I could have had a join based on date diff, saying, okay, the last 3 months, because I know there's going to be 3 rows there. That was the problem with my data. I didn't have that guarantee. Now in SQL Server 2005, we got row number. And row number means whatever my result set is, I can add a column that is guaranteed to go up by 1 for every row. And that makes my join for the moving average a lot easier. So here is my basic query, and the only thing I added is 1 extra column, a row number column, which starts at 1, goes up by 2, by 1 for every next order date, so 1, 2, 3, etc. And then for the next salesperson, we start at 1 again. And then I can use this CTE to join to another copy of the CTE. Obviously, we want to join on the same salesperson, and the row number has to be between the current row number and the current row number minus 4, which gives me the current row and the 4 previous rows. In this query, compare that to what we had before. That was this query. So this query, if you have this query in your inherited code and you're running on SQL Server 2005 or 2008, you can replace it by this, which at first sight may be equally long, but here we have three references to the same view, which might be a 20-line query, and here we have that view only once. This references the CTE. So now we have the 20-line query only once. The code is shorter, it's easier to understand, and it runs faster, especially if you're in the wrong database. That runs really fast in the wrong database. I found that if you really want to have the best performance, row number is not the best solution in all cases. For this specific situation, perhaps not all situations, but in this specific situation, a cross apply with a top 5 is faster than using the row number solution. Not as easy to understand for people inheriting this code. And when I write code and think about maintainability, I like to keep in mind that whoever inherits my code later might be a crazy ex-murderer who knows my address. If you had to have different specifications, you still had very painful solutions in SQL Server 2005. This solution, join on row number, will not work if you have one moving average over 5 rows and another moving average over 3 rows. because then you still have a join and another join, which gives me way too many rows and duplicates. So what you could do, you could still use the row numbers, and then for every column do a subquery with a join specification based on the row number. Slightly better than what we had in SQL Server 2000, but still not really ideal if you have 20 columns, because you have 20 subqueries in that case. You can also use a cross-apply version, which is also in some cases better than this. So if you have this, you can either use this solution or this solution and just test which one works best in your case. Neither of them is really great. So I would still consider upgrading to SQL Server 2012. We'll see why later. And again, inspired by what I got from Peter Larsson, I also found a way here using apply and top. This is the fastest way for SQL Server 2005 and SQL Server 2008 to solve this problem. Fastest, but again, not necessarily the most intuitive one. Now, if you want to look forward and backwards, then the slow version can be easily adapted. Because now, instead of joining, so the original slow version says where row number between row number -4 and current row number. To look forward and backward, you simply do a between. Wait, that's the wrong one. Let's find the correct one. We do it between row number -2 and row number +2, and you see that in this case the cross apply will look at a few rows before and a few rows after the current row, and you will get your moving average centered around your current row. So yes, this gives us the results, but yeah, the comment already says it's slow. And I'm not going to run all the demos, because even with 19 minutes I still need to make sure I don't run out of time. And then if you want to be faster, then yeah, it works, it's fast, but really, do you really want to have this code inherited by the aforementioned crazy ex-murderer? I would put in a comment saying this query was written by, and then not my name. Maybe Peter Larsson. That would be nasty. So, and again, it adds up. We have 5 references to the view here. Again, imagine it's a 20-line query. We have 100 lines. Yikes. Last demo for 2005, and then we will finally move into the current decade, is the deltas. If you want to show the difference between the current and the previous rows, again, row number is ideal. Use the same CTE numbered rows to add a row number to your results. Then join numbered rows to numbered rows on row number -1. Why do I have a left join here and not an inner join? Anyone? Yes? Because of the first row. If you do an inner join, then you lose the first row, because the first row has row number 1. Join says join to row number 0. There is no row number 0. You lose it. And in this case, because I have a left join, the first row will simply not show a delta, which is correct, because there is no delta to a previous row. And this is just for the curious among us. I often debate whether I should even leave this in or not. After seeing for some problems that apply and top give us a better solution, I decided to try it here as well. It gives us a solution, apply and top. It's slower, it's more code, it's harder to understand. Don't ever use this. Okay, welcome in the current decade. 2012. In 2012 we finally got more functionality in the overclass. Still not a full implementation. There are still some things in the overclass in the ANSI standard that SQL Server doesn't have. But the things we got really helped us for a lot of problems. Not for the ranking functions. Row number, rank, dense rank, etc. For those functions, the overclass has not changed since SQL Server 2005. No functional changes at all. But for aggregate functions, the sum and the average and the count, we got windowing extensions. They're great. We also got some new analytic functions added that use the overclass, but we're not going to talk about them in this presentation. It's only 90 minutes, it's not a full day. So, what exactly are windowing extensions? If you have an aggregate function with an overclass and you add windowing extensions, then some things are still the same. You still partition results in independent groups based on a partition by, but then you define a window on that group. So you already have a partition, and then it's like a window. And what is the effect of a window? Well, when I look at through a window, I see part of the audience. I don't see you there. The nice thing about the window in the overclass is that as we move through the results, the window moves along. So now I see all of you, but I don't see you anymore. And that's what we do with those windowing extensions. We have a way to, after defining the partitions, say, okay, now we do the aggregation not on the entire partition, but only on the part you can see when you look through this window. The basic syntax: over, partition by, optional. Then order by is also optional. If you leave out the order by, then you simply get the overclass that we had in SQL Server 2005. All the demos I showed you for SQL Server 2005, SQL Server 2008, I am running SQL Server 2012 on my laptop, but because I didn't use the order by clause, I got the behavior we had in 2005. To get the new behavior, you have to add the order by clause. The order by clause tells SQL Server, hey, there's a window here. And here's how it's defined. You define an order. In the case of this window, the order is defined by where every one of you is seated. So the order in this case is based on a geographical position from my perspective. And this defines how big the window is. It's a rows or range specification defines how big the window is. Is it this window? Is it this window? Is it this window? This window? They don't have to be symmetrical. They can be just the way you define it, and that's specified in the rows or range specification. So looking at the rows version first. The row specification reads rows between something and something. And the first something defines the start of the window, and you can specify it as a number preceding, as the text unbounded preceding, or as current row. And the end has a similar specification, except there you usually use a number following, unbounded following, or current row. When possible, try to use unbounded preceding as the start. When possible is the key word here. Never, ever, ever do something for optimization if it invalidates the results. Nobody cares how fast incorrect results are produced. If you need something else for correct results, forget about this. If you can do it with unbounded preceding, then do so. Because there is something called fast track optimization. I'm not going to go into internals here, it's not in scope for this talk, but it really helps performance a lot if you can use rows between unbounded preceding and something. So here's the same demo I had before. We're still partitioning by partitioning, and we're now also ordering by order, and then we have rows between two preceding and one following. So when we are evaluating this marked row, rows between two preceding and one following means this is the size of the window. Why this? Well, two rows preceding, one row following. This defines the window. So what happens at the boundaries? Well, for this row, the window is simply smaller. Yes, there is a row preceding here, but there's no data there. So it's like when I move this window, when I'm here, I only see 3 guys. Now the number of people I see increases, and now it's just the cameraman. The partition boundaries are always respected. So if you have a partition by defined, then this following row is not really a following row. It's a new partition. So again, here the boundary ends here. If you specify rows between unbounded preceding and something, then we always start at the start of the partition. It's like I do a window like this. You see that this hand does not move. You guys are always in my window. Similar for unbounded following. In this example, current row. Well, current row means actually what it says on the cover, the current row. Very simple. You could use 0 preceding or 0 following instead of current row. Of course I tested it. I'm a geek, I test that stuff. And I will never use it because current row is so much easier to understand. Now if you use a range specification, range between start and end is very similar. But you will notice that there's no number preceding or number following. With a range specification, you're limited to unbounded preceding, unbounded following, and current row only. No other specifications are allowed if you use range. More important, there's a small behavioral difference. That behavioral difference is only ever relevant if your order by column is not unique. So in this case, in the order by column, you will see 2 values 3. There's a duplicate here, which might be fine in your data. It's perfectly valid to order by something that is not unique. And now there's a difference. If you say rows between current row and unbounded following, then you will always get only the rows that are presented later in the result set if you order by that column. For a range, the window is defined by the values. So range between current row and unbounded following says in the current row the value is 3. So the window is defined on everything with a value 3 and higher. That means that for the range specification, these 2 rows look at exactly the same window because they have the same order by value. That is the only difference between rows or range in the specification. Very minor, very subtle difference. Oh, and then there's one thing, range performs way worse. Who cares, right? Well, I care about performance, and that's why I also want to point out something in the defaults. One default that I personally dislike, but doesn't really ever hurt someone, is you can just specify rows start or range start. So for instance, what I often see in posted code is rows unbounded preceding. Rows unbounded preceding means the same as rows between unbounded preceding and current row. That's one of those factoids which you have to memorize, or you have to look it up. And I don't like it. I like to be explicit in my code. It's just a few keystrokes extra. Come on, people. Use a tool, use SQL prompt, or if you don't like Redgate, use SSMS standard, what's it called, IntelliJ nonsense. There are tools for that, or just type. It's not that many keystrokes, it makes your code way easier to understand. Okay, with that off my chest, there's one other thing. You can also exclude the rows or range specification completely. You can just say partition by something, order by something, done. And order by something means there is a window. And then you don't have a rows or range specification. So how is that window defined? Well, that's where the default comes in. Range between unbounded preceding and current row, which is in most cases just a running total, except for this small thing called range. if your order by column is unique, then you will never notice the difference until you look at the performance, because range performs miserably. So always add that order by specification. If you need this, type rows between unbounded preceding and current row. If you really need this with range, still type it and add a comment saying, sorry, Hugo told me never to use it, but I really need this. I know it performs bad, but I really need this. Go complain to the manager who requested this functionality. Or something like that. Demo time. I'm going to skip the percentage. Why? Because the solution we had in 2005 was close to perfection. It can't get much simpler than we already had, with this basic overclause, and really nothing changed in SQL Server 2012. It was simple enough. But for running totals, remember, in 2005, this was our running total solution. In 2012, it's this, which in my mind is easier. And yes, if you've never seen this, then you would have to look it up. But once you know the clause, this immediately says, hey, I'm going to do a total of all orders, no partition by, so I'm going to look at all the rows. I'm going to order them by salesperson ID and order date. And rows between unbounded preceding row and current row, it means every row before me. Hey, that's a running total. And this works. If you look at the execution plan, you will also see that it's a long line of computation and only a single access to the data. So the data is accessed once and then everything is happening that needs to happen. Everything can still be a lot. If you have a lot of different specifications, you can get some orderings, you can get other sort operators, but it's fairly simple. Now here's the shortcut, rows unbounded preceding. Like I said, I don't like it, but I need to tell you guys because I'm sure nobody of you will ever use it, but you will inherit this code. If you have different specifications, well, that was where we started to get miserable in the old solutions. The different specifications, you had nasty solutions such as this or this. And now we simply remember the original one, order by, or two identical specifications here. Well, if we have different specifications, then we just have a different specification here. Here we say this running total resets for every salesperson. Then within the salesperson, we're going to order by the order date. And this also runs very fast, but still a very simple execution plan. Yes, it's a long line. There's a lot of logical operation going on. But the data access is done only once. Now, if you need multiple different specifications, then do so. But realize what happens. In this case, I'm going to partition by salesperson ID here, and I'm going to partition by name here. This is nonsense. Salesperson ID and name are correlated. The name of a salesperson and the ID will probably, well, there might be non-unique names, but it's unlikely. So this is complexity for the sake of it. But SQL Server will have to do extra work here. The line has grown longer. There are multiple sorts here. There's a sort here. And then there's a sort here. And then there's a third sort here. Sorts are expensive. We get the same result by partitioning by salesperson ID both times. And now we get a sort here. It's one. And that's it. We just eliminated two of the three sorts. Now obviously if you need a total over all salespersons and a total over all regions and a total over all colors and a total over all customer sizes or whatever, then do so. The query will still be simple, the complexity will only be in the plan, but do realize that adding more complexity always comes at a cost. Even if the query itself, with these windowing extensions, is easy to understand and easy to maintain, the performance will be affected by the complexity you added. Moving averages. Remember those extremely long queries we had for the moving averages with 5 or 7 references to the same table? Well, not anymore. Instead of rows between unbounded preceding and current row, we can simply say rows between 4 preceding and current row. And then we get our very simple query with the correct data that we wanted. If you have different specifications, if one has to look 3 rows back and the other has to look 4 rows back, remember this is where we started to add subquery upon subquery, apply upon apply, 5, 7, how many copies of the table. These were the hideous queries that were so complex that I even needed the help of Peter Larsson to come up with them, because they were beyond what I could produce. And here, with SQL Server 2012, we just have this query and we get the results. And if you want to look forward and backwards, well, rows between 2 preceding and 2 following. Rows between 3 preceding and 3 following. Life is easy. Life smiles upon us. We're happy. No more problems in our world anymore. Okay, at least not related to this. We still have our boss shouting at us for other reasons. Looking at the difference with the previous row, we could use the same trick. I could say, okay, I want to have the sum of all orders in a partition defined between 1 preceding and 1 preceding. Normally the endpoint would say following, but this is actually valid. You can have preceding and the endpoint. So over plus a window that defines only the previous row between 1 preceding and 1 preceding gives us just the previous row, and this works. However, there is an easier way. There is kind of a synonym for this, but a synonym with some extra functionality, which is called lag. Lag is one of the functions that was also introduced in SQL Server 2012. And lag order count is actually the same as sum order count over this whole precision, this whole expression. So lag simplifies this even more. Lag says look at the previous row. We also have lead. This gives us the same result. And I also have some slides to explain this. Lag, look back to the previous row. Lead, look ahead to the next rows. That's the syntax. And how does this work? Well, as you saw in the syntax, I used a lag column, but there's also an offset and a default parameter. I didn't use them in my demo, but what happens when you do use them? So let's say I use lag value 3 minus 1. 3 is the offset, minus 1 is the default. What does this mean? A lag means look back. 3 means look back not 1 but 3 rows. So now we're not looking at the previous row but 3 rows back. To understand the default, I'm going to look at a lead example. So lead says look ahead. We're going to look ahead 5 rows. Hey, 5 rows from this, we've just crossed the partition boundary. So there is no row 5 rows ahead of this, not in the same partition. And that's where the default comes in. In that case, we're going to return minus 1 to say there is no row there. We don't have a lead 5 rows ahead of us. If you don't specify the offset, the default will be 1. If you don't specify a default, the default will be null. Do we still have time? Yeah, we have some time. I started late so I can go over. Time for dessert. Salt and pepper with dessert? No, thank you. Rather not. No overclause now. We're going to do something completely different, but it's also something that was introduced in SQL Server 2012, a new way of paging. This is this is the Dutch Google, but what I want to show here is we're on page 37 of the search results, and it's page 37 of about 112 million. Who thinks that Google returns 112 million pages to my browser when I submit the search results? Who thinks that every time I click next, volgende is next, who thinks that every time I click next, a query runs on Google to produce the next page? That's what happens. And it's not a SQL Server query, but we all face similar issues in our work. And we want to solve them. And that used to be hard until SQL Server 2012. Oh, I forgot this demo. I wanted to show the performance difference between rows and range. Sorry, that's a demo I added later and I forgot that I wanted to run it. So, moving back to salt and pepper, moving back to the over clause. I just want to show the difference. There's two queries, they are the same. This is one, this is the other. There's one difference, rows or range. I added an into oblivion, which means that the results will not be displayed on in Management Studio. I do this because it's a lot of results and Management Studio renders quite slowly. So if I don't do this, then the performance of both queries will be measured by how fast Management Studio can render the results. I want to see how fast the query performs. So hence, I'm going to drop the results, but I do want to show the difference in statistics I/O and statistics time. And I'll run both queries. And that takes some time. Then it's better to just do one query at once. I just realized that it's better to do one query at once. So first the one with rows. Like I said, rows, it's not the default. If you leave it out, then you get range. Rows is pretty fast. I get my results in just 1 second. Moving here, we see that the actual execution time is even a half second. The sales order detail table has been read. There is a work table, but as you see, the number of reads and writes to the work table is 0. It's not used. And we finish in half a second. Now looking at range, same query with range. This is going to take a while. 4 seconds, no, 2 seconds. It was 4 seconds when I tried it yesterday, but my computer is in a better mood today. 2.5 seconds time. And why? Because there is quite a bit of I/O going on a work table. SQL Server has to store data in a temporary table so that it can reuse previous rows in case there is a duplicate in the order by specification. And yes, that costs a bit of extra time, a half second versus 2.5 seconds. Only 5 times as expensive. Well, it saves me typing one line, so here's what I never want to see in production. Just type that extra line. Good. Paging. I'm not going to use the views here. I'm going to use the sales order header table, the total sales order header table, which is quite large, and this is just 1,000 rows. It's a very large table, and I want to show paged data. So here's a report. The report returns 4,000 rows, and it needs to be paged. So we have a stored procedure that has the rows to skip and the rows to serve. And then I'm going to use, this is how we did it before SQL Server 2012, a top rows to serve, and then we're going to skip everything in the top rows to skip. You see that the same join is here and is here. We have to repeat it twice. The query is clunky, it's hard to understand. Yes, it works, and it's slow. This didn't work before SQL Server 2005 because you couldn't use a variable here. Before 2005 you could use this, but you had to use dynamic SQL because you couldn't use a variable in top. This version actually worked on SQL Server 2005, but really, who wants to maintain this? On SQL Server 2005 and SQL Server 2008 we could use except, but again it's complex, we have to duplicate a lot of logic. Or we could use row numbers. Couldn't really do, I didn't really have enough data to determine which was faster. What I want to show is how on SQL Server 2012 this works. And now we have the query once. This is the basic query that returns everything. I'm just adding 2 extra lines, offset rows to skip rows, fetch next rows to serve rows only. No overused, but still a very fast, simple solution, very maintainable code, easy to understand. So here's the syntax. Order by, it is part of the order by clause. So you need to have an order by, otherwise you have no defined paging. And then you say you have this offset, you have this fetch. They are optional. You can just use order by without anything, then you don't page. Or you can say only the offset, and then you just skip a number of rows. Or you can specify both an offset and the fetch next. You cannot do only the fetch next without the offset, but you can specify an offset of 0. Some syntactical call sugar, row or rows, first or next, whatever. Now here is where reality kicks in. These were all very simple examples. In reality, you will get a requirement such as give me a report that gives me the number of orders with a cumulative and per salesperson and overall. We want to show a percentage, we want to add a running total, it has to support paging, we need to see the changes, all these things I showed, running totals, moving averages, difference with the previous row, they are often combined on a report. And that's when our life really starts to get very complicated. I'm not going to talk you through the entire query because I don't have the time for that. But I did manage to find a way to do this report on SQL Server 2000. Here's the query. Maybe I should scale this down a bit. So, yeah. Easy, right? This is the query I showed you at the start of the presentation today. It's an actual query, actually works. I'll scale up again so that we can see what's going on. The total number of references to the same view, there's the last one, is 10. Did I already mention that this could have been a 20-line query or even a 100-line query? Yay. It works. Just this part. Correct database. Come on. It works. May not be the fastest query I've ever written in my career. But on just a very small data set, it produces data in 6 seconds. On a large data set, it might be 6 days or 6 weeks, but hey, it works. Stop complaining. And please don't tell anyone that this code is my fault. So let's move to SQL Server 2012. Let's just skip 2005 and 2008. We'll move to 2012. And here is the same code. It's also slightly faster. It's the same results, it's the same requirements, it's a single page without having to zoom in. This is what I wanted to show you today, over clause and its incredible power of making previously hard to solve problems that resulted in hard to maintain queries, simple to solve with queries that I will never be embarrassed about. That's what I had for today. I think I'm technically within my 90 minutes because I started late, but everyone is already heading out for coffee, so I won't keep you. I will be here all day for questions. You can, of course, email me later if you still have questions. Please also fill out the evaluation. When you click the download link, you will be asked to evaluate my session. Please tell me what you liked, and most of all, tell me what you didn't like and why you didn't like it, so that I can learn as well. Our amazing sponsors, without these companies, this conference would never have been possible. So give them a big hug if you find them. And that's it for now. I hope to see you all again after lunch and enjoy the other sessions today. Thank you for your attention.